Hey guys, my name's Peter. How are you doing? Yes, so where were we? CAN bus, that's right. CAN bus last week. That's what I was working on, and this is what we will continue with this week. So CAN bus is the bus that is used inside vehicles to communicate between different components. It is not only used in cars. It's used in many other different systems, and it is used very much in automation. So it is a very important protocol system bus that is used. So previously, I was spending time on Arduino, setting that up, getting that running so I could connect a board, and most of it was pretty much just sitting there, getting the board up and running. And I eventually got it running in USB serial, transferred, and so today I want to jump into the actual bus itself. So back here I have a book that is for projects to do with Arduino. It's the CAN bus companion, projects with Arduino. I picked that up from Amazon. Dr. Dogan Ibrahim and Ahmed Ibrahim. So I had a quick browse of this. It is really, really useful as a high-level sort of introduction into the bus and into the protocol. Now, the projects that I've seen require 2 units, so I've ordered a couple of more units, so I don't have them with me yet. And so I wanted to see if I can dive into actually developing maybe an experimental protocol in C, like creating a C library to encode and decode frames in binary data and send them up sockets, just as a validation of how the bus works, just to reinforce the idea. And then I will jump onto the actual project for decoding the data on the bus through the MCP2515 board. So the MCP2515 board is a standard prototyping board. It's a standard CAN bus controller board. You can get these boards for like $10, $20 on Amazon, really, really cheap. And they're really good at interacting with the bus. Now, there's a couple of problems that I have at the moment and that I'm going to have to work out because we have a car, but I don't actually have that opened up, and I don't really want to use our main vehicle as a playground for CAN bus in case I blow it up. So I'm going to be looking around to see if there is any kind of cars that I can find, maybe or even not cars, other ways that I can build a CAN bus. So in the meantime, I'm going to explore the actual frame data on the CAN bus, and we can possibly look at more projects to do with the actual units in the following weeks. We'll see what happens. We'll see how far we get today. I'm just going to dive in, maybe start coding like the C struct. We have the bus, we have a PDF that has the MCP 2515 controller. I'll also use this book as a reference guide for getting information about how to decode the bus packets. Now, like I said, every single project in this book has got 2 or more Uno Mega 2560 projects. So basically, I need those units, and I need 2 Arduino Unos plus 2 MCP2515s, one for receiving data, one for transmitting data. And I had no idea because when I started last week, I hadn't received this book yet. So I'm basically just digging into it now, and I'm going to explore this book and explore the ideas and the bus along with you in the next 30 minutes. So let's dive in and let's figure out what we can in the next 30 minutes about the CAN bus. During the week, I'm going to do some more reading and approach it with a pragmatic kind of, I'm going to do a little bit every week and until I get a good understanding. Now, it's good to have some understanding of C, some understanding of binary data. If you're more of like a web development kind of high level structure, it's good to sort of get an idea of digital logic first, and this may be kind of like over your head. So let's dive in. Let's get into CAN bus. Let's explore. Let's do it. So what we're going to do is just quickly get started right into the structure of a CAN bus frame. So I'm going to look at how I'm going to install extensions related to C compiler, no, C Makefile, maybe Makefile, something to do C Makefile. So something to generate C Makefile tools, provide Makefile support VS Code, C IntelliSense, build, debug, run. Okay. Create a C++ with pre-configured Makefile creator. Let's see. All right, Makefile. See, let's try this one. Makefile tools. But that's C, C++. I mean, it's C, C++, Makefile project. This is generating simple C++ project structure together with a Makefile, which fits almost 90% of small project needs. That's really what we want, right? Okay, let's install this. 3.5 stars. Let's listen to this one. Right click on a folder, quick create Makefile will be asked. Yeah, because the idea is with C and C++ files, you kind of have to build a Makefile. And I'm looking for something to quickly generate Makefiles for C projects. It's just easier, it makes life easier. Okay, so this one looks, Antoine, also known as Zenor. All right, create Makefile. Install this. This is funny because it's like Makefile tools and it's like 2.5 stars. So I'm not going to install that one. Yeah, 35, but it's got, what? 35, this whole download thing, I don't know. Wait, one review, 50, I don't know. Version 003, version 0, preview, 3.5, this C. The last published version was 2019, that's old. Makefile, what about Makefile generator? Just Makefile. Makefile tools. Yeah, no, that's pretty much it. I mean, this kind of stuff is like really kind of ancient. You kind of build Makefiles for projects, and they basically work on dependencies, and you kind of it sorts all that stuff out for you. You can take managing Makefiles is a bit of a headache. I'll try this one. Whatever, let's try it. So how do we use this? Extension will activate when it finds a Makefile in your Look, look, let's just do this. Right click on a folder and click on create Makefile. You'll ask for the main target, main by default. All right. Look, let's just, and then C. We have a C highlighting, C code. C IntelliSense this installed. Extension pack. What does this do? Theme C make. Okay, well let's C make. Colorization. Okay, let's create a new. I've got a new folder. Open folder. Clone repository. You have not yet opened a folder. Let's open a folder. Developer. Scratch. Scratch. We're gonna just experiment with stuff here. Create a new folder, and we'll just go CAN bus test frames. All right, here we go. All right. So, I mean, it's my folder, so of course I trust it. All right, let's create a new file. New file. Like a frame.h. All right, so we have frame.h, pretty simple, and let's go main file main.c. So the way that the easiest way to do it is, I guess we would just go into here and throw in a struct, which will just define the CAN bus struct for us. Really simple stuff, right? Struct CAN bus frame. It's called, what are they called? I think it's called a standard frame. Standard frame. Struct standard frame. All right. We don't need to do anything. We'll go end of type def. I think it's like struct type def. I'm trying to remember how type def something like that, right? Okay. Mail. I would rename that one to Maven. Oh my god. Activate proposition. Campus frames. Oh, a Makefile. Let's see. Makefile. No. Let's. Sometimes I wonder. It said, didn't it say you could just right click on the folder? Maybe if I need to do this, a new folder. Okay, new folder, source. Move this in here. Move, yep, and rename this to main.c. Okay. Now here we are in source. Can I make a Makefile here? Create Makefile. Yes, I can. All right, so what we're going to do is we're just really simply just going to include our dot frame dot h in here. Doesn't like that. Squiggles are disabled. Right, a /. Yeah, there we go. /. I think I might have been used to the old Windows / Anyway, okay, so we have void main. Oh, cool. And we have our printf. We need to include our stdio. Include stdio.h just to validate what we're doing here. What we're going to do is we're going to put all the structure in the frame.h and then just do everything, all the code in here, just to test it, and then we'll go from there. So this is hello worked world. Okay, and return 0. And here we go. Happy days. Let's make a makefile. Create makefile. Name of the executable. Let's just call it CAN bus frames. All right, we have our makefile. Let's see, C, C#, G++. All right, exec. Okay, now let's open our terminal. Do you want to makefile tools? Yes. Ah, all right, whatever. Okay. Let's open the terminal. Reveal in Finder. No. Where is my terminal? There we go. Just select. No, I don't want a remote window. I want a terminal window. Where did my terminal go? Normally there's a terminal, surely. Terminal. View, terminal. Ah, here we go. Terminal, new terminal. There we go. That's what I was looking for. Okay, CD source. Go make file. Nothing to be done for makefile. CMake file. And now we just. All right, go back. So I'll just cut this bit out here. All right, so let's fix this with the include here. And there we go. So if we change frame.h now, we should be able to just make, yeah, okay, build. So that's fixed the makefile. We only have the header file and the C file. Basically, I added a dependency on the include files to the executable files. And the executable file step is this, which is the compiler. So, all right, back to this. We have our frame, we have our short here with the standard identifier. So let's quickly basically finish this up by showing exactly what this frame should look like, and we'll just we'll create one and maybe print a few values. All right. So we have the, let's see, what do we have? What do we have? We have the RTR and remote transmission. Again, RTR, remote transmission bit 1. We have the control bit, control CTRL, control 6 bits, child control, which is 6 bits. And now this is the one where we have the CAN frame. Yes, we have the standard CAN frame. This really, I mean, it's it can be 0 to 64 bits, right? Now, let's see. Okay, so it's in bytes, right? So it's in bytes, just clarified. So the actual number, so we go, data is in char. That's okay. Whoops. char array, char array, char data. Okay, back to C syntax. Man, when oh yeah, that's right. This is what happens when you don't use C for years. I think the last time I coded C was in like 20 years ago. I did C++ more than, no, probably 20 years ago. No, it would have been, yeah, 18. Last time I did C was 2009, C++, before I moved to Objective-C, and really C and C++ kind of like went to this wayside, but you know, it's still fresh. I can still code it. So we have the CRC, which is 16 bits, you know, so it'd be short CRC data, and then we have our Let's see. Okay, it doesn't like that either. Incomplete char. Char not allowed. How's it incomplete? 5. I need it. Oh, I need a size. Oh, I need a size. It can't. Yeah, it won't let me do it. Ah, dear. Data. Yeah, how do we do that? Data size. So we get up to from 0 to 8 bytes. 0 to 8 bytes. I'll have to figure that out later. So 8 bytes max. Now that's the maximum size that we can have, right? The CTRL control bit. This will tell us actually no, the standard identifier. Which one? Yeah, the control. So yeah, 2 bits, dominant bit. Okay, so this 4 bits of the control will tell us the length of the data. So we have the short, the CRC, 16 bits. Then we have the ACK char, ACK, 2 bits, and then we have the char EOF, 7 bits, which is COF indicator. So that's really our struct here. And this will be 0 to 8 bits based on CTRL. Now, okay, let's see. We've got our, this is our CAN bus frame. We'll go into here, we'll create a frame. We've got a struct CAN bus frame, CAN bus frame, CAN bus standard frame. No, we don't. Okay. C, struct initialization. 0. What's a struct initialization for C? Expected identifier. A frame equals. No input files. How are there no input files? C-lang error. Make source. Okay, I guess, yeah, main.c. Main should not return a value. Okay. Yeah, that's right, because it's not. Int. Void doesn't return a 0. Great. Okay, so there you go. You see? Now we've built our little tool. Let's see if we run it. CAN bus frames. CAN bus frames. Oops. Hello world. Great. We got it. So we've got everything we need to get started. So now we have our little tool we're going to build on. Now we've got a little struct. And so what is the struct for a standard CAN bus frame? A standard CAN bus frame starts off with, I don't know if we can, what kind of type diffs. I think we only have char, right? We don't have byte. No, we don't have byte. Byte, no. Byte, no, we do have byte. Byte. Start of frame, SOF. And this should be 1 bit equals 0. Let's see. I don't think we can do that, right? Char, start of frame, 1 bit. Yeah, so what I'm doing here is I'm actually defining the bit width for this. So we're going to have packed struct. Now in C, do we have, let's go packed. I don't think there's anything packed. Yeah. Packed basically means, set frame packed. What is it not like about that? Expected. Do I need this here? Nope. Packed. There we go. Basically, what that means is we're going to packet the struct, right? It means that when we read this memory, it will give us the structure as it is. It's not going to align any of the fields. It's all going to be like the first bit of this struct will be a single bit. Then the second part, which is This is a char. This, I think we have short. Yep, short is 2. So this is a single byte, 8 bits, right? Char is generally. Short is 2 bytes. Short, half word. You know, you kind of should know all this stuff anyway, really. But it's good to refresh my own thoughts about it. So let's see. What was it? It was the standard identifier. Standard identifier. 11 bits, right? Oh, what the? No, it doesn't like having packed here. Well, can I do that? With a const type def standard frame test frame. Why? That just stand. Okay, so basically, I don't know why. I mean, this might not even work again. Let's just try and compile it anyway. No, let's see. Make nothing to do. Make a clean. Or does that make all? Make no rule to make. What does that mean? No rule to make main.c needed by. What does that mean? What? What? Did that delete the source when I did clean? Make all? Like treating C input as C++ when in C++ mode, this behavior is deprecated. So if I make should detect that there's been code changes, right? So if we go to Makefile, we got source. We've got the source, right? And the source object, and the source should be dependent on inc. This is inc. And so we have include equals name.h. All right. So basically what happens is source is this, but object is equals this, object lb libs. All. Make all. Wait, so see, make clean should remove the object files. If we make all, exec is dependent on. Okay. Make file lang. Ah, ha, ha, ha. Make all. Make all, make clean. Make all? Did that work? That was working. Nothing to be done. But then if I change frame.h again, no, nothing to be done. So the joy is include. No. Nope. Okay, main.c, no. Frame.h. Frame.h. Nope. So, look, let's see. Yeah, all right, so. Looking at this, LD flags, F sanitized, so we don't care about that. Got the CXX. Include should be include frame.h. Basically, I completely forgot how to initialize a C struct, but in C99 you can do it like this. So we can then choose which one dot equals 0, I think dot crc 0, dot troll equals 0, and dot data equals 0. Equals, yes, no, that won't work. To initialize it with 8 bytes. 0, 0. And I don't think that that's how you initialize arrays. 1, 2, 3, 4, 5, 6, 7, 8. It's like going back to school. Expected an expression because it is data error type. Char array. Now, okay. Okay, so same thing. Standard C and CC. Let's go 0, 1, 2, 3, 5, 6, 7, 8. Yep, all right. Back in the swing of C. Did it EOF 0 dot 0. And then dot SOF and standard identifier. So basically we're setting everything to 0 here, right? It's an example. Now we could have done a malloc and just set the memory to 0. Yeah, I could have done that. But the reason I've done this, okay, it doesn't like this. Oh, yeah, because I haven't set the final version value. Now, I want to see what happens if I set the start of the frame to, I mean, do we have to have an order here? Does it matter? SOF. No, it doesn't matter. The order doesn't matter. Now let's see, compile. Yeah, it compiles. Great. So the start of frame is 1 bit, so we shouldn't be able to set it to 2. See? And it probably will set it to 2. No, it can't because it is bit depth, bit field. All right. You can set it to 1 though. Oh, okay. Uchar, unsigned char. Okay, let's have a look. So we need to set it to, let's see, unsigned char. So we have to do all that again. Unsigned char. That's right, because you can set it. Yeah, that works. All right, so basically we have our basic structure. We can initialize it. I mean, that's a start. I've defined it. I know what the structure will look like. And so from here, I can start building on it. So for now, that's it. It's another short video, but next we're going to jump back in and continue building this. And so I'll catch you later. Okay. Canvas, canvas, canvas. So what else? It's been an interesting week. As always, you know, it's good. Not too bad. Not too bad. Bad. Yeah. You know what? I'm gonna. All right. That's for next week. That's for my vlog. I'll save that story for my vlog. So if you want to check out some interesting stories about interesting things, and if you want to know more about me, go and check out my vlog.